everyone. My name is Rick. I'm a bioinformatician from Milan, Italy. And I'm here with Federico Marini, also bioinformatician and coordinator for the e-Rum 2020 program. Today, we are really excited to introduce our first guest, Stephanie Hicks. Welcome, Stephanie.
Hi, thank you, everyone. So thank you so much for the invitation to join this interview. I'm very excited to see how this goes.
We are excited. So Stephanie is assistant professor in the Department of Biostatistics at Johns Hopkins Bloomberg School of Public Health.
Yes.
And also a faculty member at the Data Science Lab there. Okay. But she also known for as a co-host of the Corresponding Author podcast.
Yes, right.
Yes, and a co-founder of Our Ladies Baltimore.
Oh, yes, right.
And finally, she is one of our keynote speaker at the e-Rum virtual conference, of course.
Yes, I am.
So
very excited.
Before going into our chatting, would you like to add anything about you? And
I will also just state that I'm heavily involved in the Bioconductor community. So it's kind of a sister project to the CRAN community. And my talk will be focused in the life sciences, which the Bioconductor project is related to developing R packages for biological data. So I'll just throw that out there too.
Great. So yeah, Bioconductor, I've seen from your profile a lot of single cell.
Right.
Stuff.
These days, not so much, but yes, a lot of single cell.
It's enough. It's enough. What role does R have in what you do? Are you doing everything in R, or
That's a great question. So I historically have used R as my primary programming language for many years now. However, I've also dabbled in Python a little bit as well. So I helped teach a course in Python, a data science course in Python several years back at Harvard University. And so I have dabbled in Python, and then I also tried to leverage the Python packages that are so powerful for the analysis of single cell data. And I do that through the use of packages such as Reticulate, for example.
You can be the perfect evangelist for not having any more war between R and Python, but having them co-live together.
Yes, I am a strong believer in using whatever tool you need to be able to get the job done. And I don't believe there's a right and wrong related to the debate between R versus Python. They both have their advantages and their disadvantages. And I think whatever you're fluent in to be able to extract meaningful information from data, use that.
Yeah. And you remember when your first time was? Your
using
first
R?
time ever when? Yes.
That's a great question. I was a PhD student at Rice University in Houston, Texas. I think I was in my first year of my PhD, and we had to take, there was one computing course offered in our program, and it was half SAS and half R. So the first half of the course, we learned SAS, and then the second half of the course, it was a brief introduction to R. And ever since then, I've sort of just continued to dabble in it. And then actually during my PhD, we had Hadley Wickham join the department. And so he kind of transformed our computing course that was offered and changed the department for the better. And so.
Was it that thing that he was referring to in his recent interview when he kind of established basically the whole course, when he had to take it over for teaching?
I didn't see the interview, so I'm not sure
what
you're referring to.
I can send you the link later.
What did he say? Or
I think he said something like he basically had to write it from the scratch, the whole course.
That's probably true. That is probably a fair description of what it was.
This is so nice, because in the end, so it's a whole community, but in the end, it's a village. So the size, and everyone knows what is going on, or in the best case scenario, you know what's cool, what is cool and going on. Cool.
Right.
In my case, I think this year is my 10th anniversary. So the first time I started was
the 10th anniversary
of using R.
Oh, okay.
Oh, nice.
So I'm the freshman here, so.
Well, you are just as welcome as the rest of us.
But experience was actually very, very, I was introduced to R with the Tidyverse.
Yeah, that's interesting. So there is also this, I don't know if you call it a debate or a philosophical discussion about whether to teach students, when you first introduce R, to teach students through the use of the Tidyverse or through the use of just base R, because there's the concern that if you, for example, introduce someone with only the Tidyverse packages and then they go on to do something that's needed, that's not offered in the Tidyverse, that's currently offered in the Tidyverse, then they're going to have to learn base R eventually. They're going to have to learn some syntax. And so while the Tidyverse is able to kind of shield them from that during their introductory phases, there's this concern that they're going to like hit a wall essentially, and then they're not going to be able to move forward. So I've also had this discussion with many other people, and I think my kind of personal opinion or personal response is you should teach whatever is needed to be able to get them up and running the fastest. So for example, if your goal is to teach them data visualization, like to be able to make a few plots, then teach whatever you need to be able to get them to be able to make plots. Because if somebody is new coming into the R community, it's very empowering to be able to see what just a few lines of code, for example, in ggplot can do to be able to get you to like creating a quite beautiful plot in just a few lines of code, as opposed to, for example, base R, which it would take a little bit more effort to be able to make that type of plot. And so once you've kind of inspired someone to say, wow, look what I can do in just a few lines of code, then they're willing or more willing to continue to learn and understand, well, how did it work this way? And what else can I do? And what other packages can I try? So I'm a big advocate of trying to get them up and running the fastest and then letting them explore from there and figure out how much more do I want to go in what area, as opposed to everybody must learn base R. So
in some aspects it helps. But
in some yeah. So for example, in my work with genomics, everything I do is with matrix multiplication. And so a lot of my work is not tidy, and I ultimately use base R. I don't know how you feel, Rick, but as a bioinformatician, a lot of what I do is in base R. And so So one of the projects that I'm focused on is how to teach students about data science. And the traditional way of doing that is to offer lectures in which you learn tools or methodologies or fundamental ideas in data science, and then you have some kind of lab component typically where you're allowing a student to practice some of the more hands-on programmatic skills of implementing, for example, a linear regression model in R or Python. And I am of the opinion that if we can integrate those two together, then we can more closely mimic a data scientist's experience. So a data scientist, for example, has his or her hands on the laptop and is learning about a method and then immediately applying it. And it's always surrounded and kind of motivated with some kind of question. So for example, trying to calculate or estimate the fraction of individuals who are going to vote for a particular candidate in an election. And so the idea is to build a repository of lectures. They're essentially lectures that start with some kind of question and then introduce a student to the data that are needed to answer that question, talk about how to get that data into R, talk about how to wrangle that data, demonstrating all the data analytics skills that are needed, and then demonstrating, for example, how to calculate the fraction of individuals or estimate the fraction of individuals who are going to vote for a particular candidate, maybe adjusting for some kind of bias or something like that. So we're teaching, my goal is to teach students or to provide an educational resource to lecturers to be able to teach data analytics skills or data science skills. And I'm doing this with our markdowns essentially. And so the gap that I'm filling is this educational resource that is quite consuming to build from scratch. Like if you wanted to do this kind of on your own, then you'd have to go find a data set, download it, clean it, figure it out if it's a good data set, and then build a lecture around it. And I'm trying to remove that barrier by providing the lectures kind of made for the instructor, and the instructor can then take the lecture and do whatever she or he wants with it. They can pull out chunks or teach the whole thing or whatever.
There's an amazing effort that is going on in the BioC community Slack also for sharing all of this educational and training resources, which is a lot of situation where you do not have to reinvent the wheel from the scratch. And that's so much liberating in terms of time and mind and thoughts, that you don't have to put it because someone already had a very nice running wheel, and then you can just say, hop on and use that. So it's a great time to be in teaching, especially with the new resources that we have. And I kind of envy people that are studying now. Say back then, I didn't have that many, say, interesting in such way oriented courses. I had a few, but and I still do remember them clearly. So they had this, the whole course was a capstone project like setup, and then you basically learn how to use the skills that you are supposed to learn for a particular aim. And that's actually how you don't forget them, because otherwise it's just textbook knowledge, and in many times you don't take it along with you. At least that's my impression. But it's a great thing, and the whole R Markdown framework enables a lot of these things quite seamlessly. Yes. So we are also lucky, actually, as instructors.
I also grew up in the same kind of framework as you. I wish that I had these types of resources, but I can only make the world better going forward. I mean, I can only learn from kind of how take what I learned and then try to create resources for others that I feel like I would have loved to have.
Yeah, that's a great mindset to have.
Stephanie, you were mentioning a gap and barriers in education, and what kind of students, what kind of backgrounds your students have, because sometimes I think that, data science, for instance, the ability of doing, of making janitor work on data, cleaning, it's of every domain.
Right. So I teach in a school of public health. So my actual classroom teaching responsibilities are, for example, students in a public health school. However, the project that I mentioned before, the Open Case Studies project, is completely agnostic to the type of domain. So our goal is to build case studies in kind of all walks of life. So some in political science or politics, some in sports, some in public health, some in genomics, and they're really motivated by current events or motivated by interesting questions that we come across. And so that has been one of the most time-consuming aspects of it, trying to identify an interesting and relevant question that we could answer with data in domains outside of my area of expertise. Of course, I could probably come up with hundreds of them for genomics, but I don't want to just have the case studies or repository of genomics. I want it to make it more interesting and applicable to other areas. And so we've been working with faculty members in these other areas, trying to help us identify questions and data sets that would be useful to others, if that makes sense.
Have you been involved with the, because you were mentioning about other faculty member, I know that Johns Hopkins is really involved in, for instance, in the developing of, let's say the MOOC courses, Coursera things, and, the online paradigm, this shift to this new kind of courses. So what's your experience with these new tools, with this new paradigm, especially related to R?
Yeah, that's a great question. So I joined the department in 2018. So the development of those massive open online courses that you're referring to on the Coursera platform were before my time. They were developed by my colleagues, and those courses are still continue to this day. However, there are new courses that my colleagues have been developing and that I've been involved in more recently. And those are on not only Coursera, but on other platforms. So for example, Lean Course is a platform developed by Lean Pub to offer, again, massive open online courses. For example, one of them developed by my colleague, Jeff Leake, is cloud-based data science. So the idea there is to be able to teach someone how to become a data scientist not just methods, but like all the professional skills that you would need to be able to go on a job interview, and I mean, everything, to go from nothing essentially to be able to get a job as a data scientist. And it's quite impressive because the idea there is to be able to teach somebody how to do this everything in the cloud. And so you don't necessarily have to have a laptop with like fantastic infrastructure to be able to do this. As long as you can access a browser, essentially, you can sign on to RStudio and RStudio Cloud and be able to do everything you need from there. You can build presentations in Google Slides, for example. So if we are able to teach, for example, a generation of people who weren't exposed to these data analytics skills when they were growing up, they could, for example, transition to becoming someone or becoming a professional who can take, for example, a raw, messy data set, apply all the wrangling that's needed to be able to get it to a point ready, for example, for modeling or some kind of prediction analysis, then that person is a very valuable asset to society, because data are incredibly messy and hard to wrangle. And it's not necessarily true that you need to have a PhD statistician to be able to do all of that. You can really train a large fraction of the world to be able to do that. And so that's a MOOC that's been really exciting to work with or see happen. And then we have a couple other MOOCs that we're working on right now.
Good.
Okay.
Good. That's fascinating. Training a good part or a good fraction of the world. It's a
I think it's a lofty goal.
Especially, I like the aspect of having it's a kind of a no barrier entry level in terms of infrastructure, because you don't need, say, a cluster computer. But
Yes.
I think what you're referring to is this Chromebook data science course, right?
It is. So it used to be called Chromebook, but then at some point it transitioned into cloud-based data science, because it was suggesting that you needed a Chromebook, and it's really not true. It's just you need a browser.
Entry level, say, in terms of price, probably.
Yes.
That's all you need.
So that course is actually free on Coursera. I mean, on Lean Course, so you can go take it for free. And then my colleague has built actually an in-person training component in the city of Baltimore. So to take people from our local community and put them through a training program. It's called Cloud-Based Data Science Plus, where they're offered online TA office hours, essentially, and they're actually paid to complete the course, so they can really dedicate their time and energy to learning these skills, and then be hired by a company. So.
I'd like to pick up on what happened yesterday night, actually, for me, and probably, today for you, the new release of Bioconductor. Is there anything that we can expect built upon that coming from your side? There was this whole Oscar initiative that was published as a companion book to the latest milestone publication from Bioconductor. But you can probably say something much more on this.
Sure. So I'll start with Oscar. So Bioconductor has these releases twice a year, and the latest one that you're referring to just came out. Was it yesterday? My time is all muddled. So
I think so. Probably 12 years ago, 12 hours ago.
Okay. Yes. So Bioconductor's next release was just announced, which is really great. 3.11, I believe, is what it was. And then I'll touch also on OSCA. So you mentioned OSCA. That stands for Orchestrating Single Cell Analysis in Bioconductor. And so that was a project that I started, almost 2 years ago now. And the idea was to announce, essentially, and state that Bioconductor's community is rich with developers of single cell analysis packages. And so there's this type of genomics data that we have in the biological community where you can actually measure individual features and from individual cells. So you can see exactly, for example, which gene is expressed at a particular time in a particular cell. And it's a super powerful type of data. And this data kind of exploded in 2014, 2015 with the commercialization of some technologies that came out. And then for the last like 3 or 4 years, the bioconductor community the developer community has really exploded, as I mentioned, in terms of developing packages to be able to analyze this data. So that was really exciting to see, but it was frustrating for me to hear that the community as a whole wasn't really being recognized for that, because it's such that the developers have their own individual packages that they contribute to Bioconductor, but the Bioconductor community wasn't really providing a resource of how to integrate all of these packages together, essentially.
A part of the workflows, right? So
yes, right. And so if Bioconductor's kind of role historically has been similar the way you could think about an orchestra. In an orchestra, there are lots of musicians and they each play their own important role in the orchestra. And Bioconductor really serves as the conductor for that community to be able to make sure everybody stays in sync and everybody plays well together and we stay on tempo and things like that. And so in terms of the world of single cell, I felt like Bioconductor could play a stronger role in being able to state that we do have this very large, rich body of packages and data infrastructure that's been developed to be able to analyze your data. And I wanted others to know about that, essentially, and to be able to use it as opposed to having to figure out how everything worked together. And so I started a project called OSCA, Orchestrating Single Cell Analysis. And what essentially that turned into was a paper that was published in December of last year in 2019. But then more importantly was this idea of an online book in Bookdown, in the Bookdown package, that allows you to essentially go from raw counts to completely process data in different downstream analyses. So whether you're wanting to do some kind of unsupervised clustering analysis, whether you're wanting to do some kind of dimensionality reduction, whether you're wanting to find differences between two groups of cells, all of it's there. And I will state that that online book has been heroically led by an individual named Aaron Lunn, and he deserves almost all the credit for making sure that that book is what it is today. I think
it's a piece of art.
It's a piece of art.
It's a castle of magics and tricks and
right.
beautiful. I can only recommend it further. So it's constantly iteratively built. So whatever you see in that, it's actually happening and working with the current setup that you might have when you install a package. It's an amazing resource. So if someone tells you, oh, but probably the documentation might be outdated, that's not going to be the case for that. So that thing is a beauty in its finest way. So
right. And I think one of the best parts I like about it, especially Bioconductor as a whole, is that it's open source, but it's also open development. And so the difference between, for example, other packages or competitor pipelines, like, for example, the Seurat pipeline or the Scanpy pipeline, those are usually or typically led and driven by one or two labs. And Bioconductor is really developed, the single cell package world is developed by hundreds of individuals. And so making that work is difficult, but also it allows for a lot more ideas to come in at a very fast rate, but it also can be very overwhelming to a user. So it's critically important to be able to provide timely documentation of how these packages work together. Otherwise, users will just say, I don't want to make all these decisions and I don't understand how everything works together. And that's the last thing we want. And so that's why it's so important to me to develop this documentation, which is essentially, a really nice book.
Yeah. If I can speak one more thing about Bioconductor, if I am that tiny good as I am now, I owe a lot of things of these developments and say improvements that I had on me as a person, as a developer, also to them. I made the jump from simple user to developer back then, and it's just a great thing that I can actually encourage everyone to try and do, because it's an enriching experience. So it's something that you can easily sell out as a CV line.
I'm happy to hear that.
Yeah, I like to hear you guys, you know, talking with such poetry about. No, it's really an experience, and I see, and now I get the meaning of, you know, of conducting, the bioconductor. So this feeling of orchestrating. And so Stephanie, you mentioned an orchestra, which is basically probably the deep meaning of all this effort from, you know, a lot of people. And I have to say that me as a, as a user first, I really experienced it. And then,
I mean, the Bioconductor core, it has, I don't know exactly, the 10 or 12 full-time software engineers that dedicate their life towards making this work. I mean, this is by no means a small task. And every release cycle, there's, you know, a whole set of problems, I'm sure, that arise with like new versions of R, and they develop the core infrastructure that all these packages rely on. I mean, it is an enormous amount of effort and energy in it, but to see it flourish is nice. I mean, to see it flourish is beautiful.
If I can actually add to this part of, say, having a workflow that works, and and the effort that actually you need to have it running. What is your, so can you share us with us? Can you share with us some say 3 aspects of your workflow that you would recommend to everyone? What are your tricks?
Oh, let's see. Twitter. So trying to keep up with the latest packages, I think, is something that I struggle with a lot. And the way I keep up with it is Twitter. So both for scientific publications as of late, in particular, and for our packages. So for example, last week, I think it was last week, or maybe it was a couple days ago, I saw the release of tidy models. So inside of the tidyverse, there's a set of packages related to essentially machine learning, and that's called tidy models. It's like a suite of packages related to um, splitting your data into training and testing, applying different types of pre-processing, applying different machine learning algorithms, and then cross-validation and so forth. And so I had been dabbling in that for a while now, but then when I saw the release of the website that they published, our studio published, then I really started to dig into it. So I keep up with various packages that way, or if somebody tells me, oh, you should definitely incorporate this package into your workflow, then I try to incorporate that into my workflow. But it really requires like a level of initiation, or I don't actively seek this out. It's too much for me to be able to do that. How do you guys identify like new packages to work in your workflow?
I would also say Twitter, say the BioC Slack is also one excellent way to keep up to pace with what's going on. Mm-hmm. This bioarchive, I would say movement, because it's not just a journal, it's not just a website, it's a movement, the whole preprint thing. I think we as early career researchers benefit a lot in terms of exposure by that, and also because say journals are nowadays, thank God, they are not say opposing to that anymore or at all, but rather they are encouraging people to have say first-class products posted on there, and then also they can also probably have a first feeling of how interesting it would be for the whole community. They can also have a kind of a proxy for that. Mm-hmm. So that, and to not overuse Twitter, I wish I had a recipe for that, but it can be a time sink.
It is. No, it is. You definitely have to have, it's a dance of like how much you want to engage with it. I tend to engage with it in a one-directional fashion where I use it for like putting out information, and then every now and then I'm like, oh, okay, I'll just take note of these other things that are happening rather than engaging all the time. So
tip number 2.
Number 2, right.
What's your tip number 2?
Let's see. So I don't enjoy maintaining 2 versions of R, like locally on my laptop and like in the cloud or in the cluster. So as of late, I've just been working in a cluster on the cloud. And this is because there's a faculty member in my department who maintains all the versions of R and R-Devel and Bioconductor Devel for me. And so don't really use a lot of R on my own laptop, so I feel like I'm becoming more cloud-based as I go on. And I feel like it's been very liberating because then I don't have to worry about like package installations on my laptop. I do have R installed on my laptop for small things every now and then, but almost all of my work is done in the cloud now. And so that's been really fun. Do you guys work mostly in the cloud or on your laptops?
Well, I do mostly on my laptop, actually, I have to say, but I have the freshman here, so that's why probably. So more and more often I do use the cloud infrastructures. Actually, I'm approaching them now, but I do use also our internal, it's not a cloud infrastructure, but for instance, our servers at the institute.
Sorry, yeah, servers, yeah.
It's not on my computer, but it depends. Yeah, but I come from a strict local computer, local installation experience. So I'm slowly optimizing it.
Right. And Fed?
For me, it's the same. So it's a balance between things to deal with locally and say the server in our institute, they are well performing. And so it's more like to finding each task to have its own place. So long running tasks might belong there, but then sometimes you just need a little more interaction with the session, and you want to do that in the most responsive way, and probably not have to depend on the internet connection.
Right.
That's sometimes also a limitation these days with these VPN servers that might be reaching their limit.
Right. Do you find yourself enjoying that aspect as opposed to like working locally, like with the, do you enjoy it, I guess, more or less?
I would say that for package development, it's quite essential to do it locally. At least
that's a good point.
That's in my hands, it works just much better to have it like that. But there is a lot of, say, goodies. I can say Docker, I can mention Renku as this cool, say, container-based solution where you basically don't have to just destroy from the scratch your laptop or to install anything. You can just grab a container, Docker-based, and boom, everything just can work and can mimicry, for example, the setup of the build systems. That's a huge commodity to have. So for this case, there's no need to actually make your computer suffer, but you can just leverage these things as well.
Makes sense.
Right. I think that we can conclude first time at e-Rum.
It is, yes.
Yeah. We won't be able to physically join in Milan, of course, but we will do it virtually next June. So we are really looking to hear from you. But yeah, I mean,
I'm also looking forward to.
What are your feelings about the global first virtual conference in R?
Well, first of all, I just want to applaud the committee and everybody involved in terms of the amount of effort it has taken to get to this point. I can tell how much you want this to succeed. And so from an outsider's perspective, I just wanted to make sure that was noted and applauded, because my personal opinion is that I am less excited about virtual conferences in general, because in the ones that I have participated in recent weeks, it's really about what people have done is essentially translate a typical conference format to online. What that means is like a speaker signs into a Zoom session at a particular time, gives a talk, and then signs back out, but there's no real engagement of social interactions. And I think that those types of conferences will not be very successful in the long run if this continues, because if you want a virtual conference to be successful, my sense is it's all about interaction. It's all about how can we structure interaction in an online setting between the participants and the speakers and so forth. And so I can tell that this conference is going to be different, and I'm really excited by that. And I think it's cool to learn about how you're bringing that to life through the use of these interviews and so forth. So, for example, I work with the Bioconductor community also has an annual conference, and they are also thinking very heavily about how can we transform what we typically think about our Bioconductor conference into something that looks different, but hopefully would be much more engaging for those individuals at home. And like for someone like me who has young kids, I cannot sit in a room for 8 hours and watch Zoom videos, for example.
Not without being photobombed.
Not without being photobombed. And so I like having pre-recorded videos of keynote speakers, for example, is like one way that we're thinking about handling this, is allowing keynote speakers to be pre-recorded so somebody could go and watch the keynote speakers in their own time, similar to the way we watch Netflix or online videos. We typically watch a lot of content on our own, but then providing the conference virtual setting as really like structured interaction time between the participants and the speakers, and engaging as much as possible. So you can, of course, get the content that you want to see, that you came to see, but then allowing the flexibility for participants to not have to sit there for 8 hours, for example. So I don't know. I'm just really excited about this conference and seeing how it turns out.
We will discover it. I don't know, but
we will bring the love messages to the rest of the team, because it's
sure.
So right now it's just 2 of us, but it's there's a big team which is putting a lot of heart and energy and mind since more than 1 year as we speak now. So yeah,
I can only imagine how you felt making it turn virtual after all of that effort. So
okay. Okay, so wish us good luck. All right, Stephanie, we really have to thank you a lot very much, because I think that some of the heat of this virtual conference will be due also, due to these interviews. So thank you for your availability, for your words, and
thank you for the
your
invitation.
presence here.
Stay healthy, and we'll be very much happy to hearing your seminar in June.
Yeah,
looking
see you in
forward
June.
to it.
Bye-bye.
Bye, everyone.
Thank you.